Dear students, this is our sixth lecture on probability. In this lecture, we will discuss about binomial distribution. So first we will see what is the distribution. The number of successes capital X in n independent trials, in each of which the probability of success P and probability of failure Q, which is 1 minus P, is a constant, is called a binomial random variable or binomial variate, and its probability mass function is given by probability at x equal to ncx p to the power x into q to the power n minus x, where x running from 0, 1, 2 up to n. This is called the binomial distribution. If there are n sets of n trials each, then the number of successes occur is n into probability of x at x. So students, here first we need to know what is this x. So x is number of successes. So consider tossing of a coin. So when we toss a coin, you will get either head or tail. So consider our target is to count number of heads. That is, values of x are related with heads. So our success means getting a head. So such x is here. If x is number of successes, then its PMF is given by this formula NCX. N means number of trials. Then P means probability of success. So in our example, P is 1 by 2. Q means probability of failure, which is 1 minus P. In our example, failure means if our target is getting head, then failure means you are getting tail. So it's probability 1 by 2. Right? So in this way, we will define PMF when x is a number of successes. So there are certain properties for binomial distribution or binomial variate. So mean is, so in case of binomial distribution, mean is given by n into p. N means number of trials and p means probability of success. Variance is given by n into p into q. N means number of trials, P probability of success, Q probability of failure. Second property, mgf about the origin m naught t equal to Q plus P into e raised to t raised to n. And third property is probability at x equal to x plus 1 equal to n minus x divided by x plus 1 into P by Q into probability at x equal to x. So property third is called recursion formula. Means if our target is to find out probability of 2, 3, 4 and so on, if you know probability at 1, you can use this formula. Consider the example. Comment on the statement that the mean of a binomial distribution is 3 and variance is 4. So we have to check whether the statement is correct or not. So we know by the properties of binomial distribution that mean is given by n into p and variance is given by n into p into q, where p and q are the probabilities of success and failure respectively. Now see here, so mean is given, which is 3. So mean means n into p equal to 3 and variance is 4. So n into p into q equal to 4. So these two things are given. The value of n into p is 3. So we'll put this value here. So n into p is 3. So 3 into q equal to 4. So q is 4 by 3. But 4 by 3 is greater than 1. And we know that probabilities are always less than equal to 1 or lies between 0 and 1. So here you are getting probability of failure to be greater than 1, which are not possible. Hence the statement is wrong. Now second example, determine the binomial distribution with mean 4 and variance 3. So mean is given. Mean means n into p, which is 4, and variance is n into p into q, which is 3. So here n into p is 4, so 4 into q is 3. So q is 3 by 4. Once you know q, we can find out p as 1 minus q. So 1 minus 3 by 4, which is 1 by 3. Therefore, the PMF of the corresponding binomial distribution is probability at x equal to x is NCX 1 by 3 raised to x, that is p raised to x into q raised to n minus x. Consider next example. Out of 1000 families with 4 children each, how many would you expect to have? Number 1, at least 1 boy. Number 2, 2 boys. Number 3, 1 or 2 girls. Number 4, no girls. And number 5, at most 2 girls. Assume equal probabilities for boys and girls. So in this example, 1000 families are given with each family have 4 children. Now here we will consider probability of success to be either boy or girl. Choice is yours. So here we will consider probability of success to be children is a boy. So here we have to assume equal probabilities, means p is 1 by 2. So probability of boy 1 by 2, probability of girl 1 by 2. So let p be the probability that the children is boy. Therefore p equal to 1 by 2 and q is also 1 by 2. Then the probability of children to be a boy x out of 4 children is. Now see here, in each family there are 4 children and we are choosing that children is a boy. So using binomial distribution we will get here probability at x equal to x, and this x is a boy for us, which is NCX. So n is 4, 4CX, probability of success 1 by 2, that is boy, 1 by 2 raised to x into 1 by 2 raised to n minus x. So this is the general PMF for this example. Now first case, at least 1 boy. So we require x to be at least 1. We have to find out this one. So probability of x कम से कम 1 चाहिए मुझे. So greater than equal to 1, which is equal to, so at least 1 means 1, 2, 3, so on. How many? 1, 2, 3, 4. So instead of that, we'll write down 1 minus probability of no boy. So which is 1 minus probability of x equal to 0. No boy means. So 1 minus x equal to 0. We'll put here. So 4C0, 1 by 2 raised to 0, 1 by 2 raised to 4 minus 0. So 1 minus value of this term, 1 by 2 raised to 0 is 1. 1 by 2 raised to 4 is 1 by 16. And this is 1. So 1 minus 1 by 16, which is 15 by 16. So this is the probability that at least 1 boy is there. But our target is to find out how many families are there with at least 1 boy. So here, so expected number of families equal to total families into probability, which is 938. Now second part is 2 boys. So probability of 2 boys means probability at x equal to 2. So 4C2, 1 by 2 raised to 2, 1 by 2 raised to 4 minus 2. So this is 1 by 16 into 6, which is 3 by 2. This is the probability that each family has 2 boys. Therefore expected number of families is equal to 1000 into probability, which is 375. The third part is 1 or 2 girls. So probability of 1 or 2 girls means probability of 1 girl plus probability of 2 girls. But out of 4 children, 1 girl is equivalent to 3 boys. So this is probability of 3 boys plus probability of 2 girls means 2 boys. So here we are considering values of x to be a boys. So we will convert everything in terms of boys. So 3 boys plus 2 boys, that is probability at x equal to 3 plus probability at x equal to 2. We'll replace these values in binomial distribution. So 4C3, 1 by 2 raised to 3 into 1 by 2 raised to 4 minus 3 plus for x equal to 2, 4C2, 1 by 2 raised to 2, 1 by 2 raised to 4 minus 2. So this is actually NCR. We know that combination formula, n factorial divided by r factorial into n minus r factorial. So 4 factorial divided by 3 factorial into 4 minus 3 factorial. So this is 5 by 8. Therefore, expected number of families equal to 1000 into 5 by 8, which is equal to 625. Next part is no girls. So probability of no girls means probability of 4 boys. So probability of x equal to 4. So 4 C4, 1 by 2 raised to 4, 1 by 2 raised to 4 minus 4, which is 1 by 16. Because this 1 by 2 raised to 0 is 1. 4 C4 means 4 factorial divided by 4 factorial into 4 minus 4 factorial, that is 1. So expected number of families equal to 1000 into 1 by 16, which is 63. Next part, probability at most 2 girls. ज़्यादा से ज़्यादा 2 girls चाहिए मुझे. So this is probability of 2 girls plus probability of 1 girl plus probability of 0 girl. So we'll convert everything in terms of boys. So 2 girls is equivalent to 2 boys. So probability of 2 boys plus probability of 1 girl means 3 boys plus probability of 0 girls means probability of 4 boys. So replace all these values. So x equal to 2, x equal to 3, x equal to 4. We'll replace these values in binomial distribution. So we'll get probability to be 11 by 16. Therefore, expected number of families equal to 1000 into 11 by 16, which is 688. Next example is, in a precision bombing attack, there is a 50% chance that any bomb will strike the target. 2 direct hits are required to destroy the target completely. How many bombs must be dropped to get a 99% chance or better of completely destroying the target? So understanding question is very important in probability. So what are the given things? Some probability is given. We will see what is this probability. 50% chance that any bomb will strike the target. So this is our success. So value of P is 50%. So 2 target hits are required to destroy the target completely. So value of x. So हमें 2 बॉम्ब सफिशियंट है टारगेट को डिस्ट्रॉय करने के लिए. अगर हमने 3 बॉम्ब यूज किया, 4 बॉम्ब यूज किया, that is also destroying the target. But minimum 2 bombs are required to destroy the target. Right? So see the solution. Let P equal to probability that bomb will strike the target. So it is 50% given in example. 50% means 1 by 2. Now let n equal to, so what is our target here? How many bombs must be dropped to give a 99% chance? So some probability is given. So let n equal to number of bombs required to ensure 99% or better chance of destroying the target. So we have to find out what is this n. So meaning of this is, that is the probability that out of n bombs dropped, at least 2 strike this target must be greater than 0.99. Let x be the discrete random variable representing the number of bombs striking the target. So here कम से कम 2. So probability of x greater than equal to 2 is greater than equal to 0.99. See here, either 99% or better. So greater than equal to 0.99. So finding this probability means find out when x equal to 2, 3, 4 and so on. So we can write this as 1 minus probability at x equal to 0 plus probability at x equal to 1 greater than equal to 0.99. So 1 minus, our target is to find out n. We know probability of success, we know probability of failure. So NC0, 1 by 2 raised to 0 into 1 by 2 raised to n minus x. But x is 0 here. Plus, so probability at x equal to 1 using binomial distribution, NC1, 1 by 2 raised to 1 into 1 by 2 raised to n minus 1 greater than equal to 0.99. So this is 1 minus, so value of this term nc0. So n factorial divided by 0 factorial into n minus 0 factorial. So this is 1. This is 1. So it is 1 by 2 raised to n plus. Now see here, this base is same. So we can add the powers. So 1 by 2 raised to 1 plus n minus 1. 1 get cancelled. So value of this term is 1 by 2 raised to n. And nc1 means n factorial divided by n minus 1 factorial into 1 factorial, which is greater than or equal to 0.99. So which is equal to, so this implies 1 minus, taking 1 by 2 raised to n common. What is remaining? So here, see here, n factorial divided by n minus 1 factorial. This is the value. So n factorial divided by n minus 1 factorial. So we can write this as, we can write n factorial as n into n minus 1 factorial divided by n minus 1 factorial, and this n minus 1 factorial get cancelled. So value of this term is only n. So taking 1 by 2 raised to n common here, you will get here 1 and here n. So 1 minus 1 by 2 raised to n is 1 plus n greater than or equal to 0.9. So this implies we will take this term to this side and this term to right hand side. So 1 minus 0.99 is greater than or equal to n plus 1. We are taking this term to this side. So n plus 1 and value of 1 by 2 raised to n is 1 by 2 raised to n. So n plus 1 by 2 raised to n. So this implies 0.01 is greater than or equal to n plus 1 by 2 raised to n. So we have to find out value of n which satisfies this relation. So when n is 1, it is 1 plus 1 by 2. So 2 by 2, 1. So 1, so not possible. So when n2, n3 and so on, by trial and error it is found that n equal to 11. Hence 11 bombs must be dropped in order that at least 2 bombs strike the target to destroy it completely with 99% or better of completely destroying the target.